Today we're talking about section 8.2, which is using properties of parallelograms. And this lesson won't be quite as interactive or quite as, interesting or different as it was in class because for the sake of keeping this video concise and short. So what we need to know is the precise definition of a parallelogram, which you see over here on the right side of the flip chart. And a parallelogram is a quadrilateral, it always has four sides, with both pairs of opposite sides parallel. So that means that this pair of opposite sides, they are parallel, and this pair of opposite sides are parallel. And when we say opposite, we basically just mean that it's across from each other. That's what we mean by opposite. So this is the basic geometric definition of a parallelogram. Now, there are four specific properties of parallelograms that we're going to look at in this lesson and use them to solve some problems. So the first two say that in a parallelogram, its opposite sides are not just parallel, they're also congruent. So these opposite sides are congruent to each other, and these opposite sides are congruent to each other. The second theorem states that if it's a parallelogram, that opposite angles are congruent as well. So these angles across from each other here are congruent, and these angles across from each other here are congruent. So those are two special properties of parallelograms. And let's look at a problem that's quite basic and simple. We're going to find the values of x and y in this parallelogram, and we're going to use those couple of properties. So if we're going to solve for, first of all, x, which is here, that's a side. Since there's no degree symbol, we know it's attached to this side. And since we know that opposite sides are congruent, we can say that x plus 4 is going to be equal to 12. And from here, we can subtract 4 from both sides, so x equals 8. Secondly, we need to solve for y. Well, y, this angle A here, we know it's a degree symbol, so it's an angle. Y is across from 65. So y will simply be equal to 65. Simple enough, right? Let's do one more. Let's do this one here, though. Find the values of x and y. Well, for x, 2x is opposite from 50, so 2x is equal to 50. And when we divide by 2, x will be 25. We can plainly see that y plus 3 is across from 18. So y plus 3 equals 18. And subtracting 3 from both sides, y is 15. Another property, as demonstrated in this theorem, is that in a parallelogram, the consecutive angles, or the angles that are next to each other, are supplementary. So angles x and y, which are next to each other, are supplementary. X and y are supplementary. X and y are supplementary. The ones that are next to each other here. So opposites are y's and x's because they're congruent. Consecutives are supplementary. This should seem familiar because since this is a parallelogram, if I extend these sides, and I consider this to be my transversal, and let's take away this just to make it a little easier to see. These are consecutive interiors. So yes, they will be supplementary. That is why in a parallelogram, consecutive angles, the ones next to each other, are supplementary, because it's actually the same idea or property we talked about in chapter 3. And the last property states that in a parallelogram, if we were to draw in some diagonals, like this one and this one, that they bisect each other. That essentially makes M the midpoint if they're bisecting each other. They're dividing each other into congruent halves. So this half and this half are congruent, and this half PM and this half RM are congruent. And that's for every parallelogram. So let's use that to solve a problem. Not this one. Let's do this one. So in this case, if we know some information from our picture. We also know it's a parallelogram, and we're looking for NM. Well, if these diagonals bisect each other, then these halves are congruent, and so are these. So if Kn is 2, then Mn is also 2. And that makes the entire length, Km, 4. For number 5, we're looking for the measure of JML. So JML, this whole angle here. And we know that consecutive angles are supplementary. So angle J and angle M, they're consecutive, they're next to each other. They're supplementary in this parallelogram. And so this is 110. So we'll take 180 minus 110, and that gives us 70. So this green angle here is 70. And finally, we're looking for the measure of angle KML, which KML, if I trace that, KML, right there, it's this half. Well, if the whole thing is 70, and this half is 30, then what's left over in the other half is 40. So that means this is 40 degrees. So there's just a brief example of how we can apply these theorems to solve for missing segment lengths or angle measures in a parallelogram. These properties only work in a parallelogram. So if it's not a parallelogram, these properties will not be applicable. If you have any questions, please send me an email or before or after school, and hopefully I can answer some more questions for you.